Here we'll have a look at some of the industrial switches that we're going to be using. Here would be a push button, and what happens to mount these things on a panel, there's like a twist lock thing going on, so you just kind of turn it and this will pop right out. Let's see, I turned it to the left. The black on black's a little hard to see. You would have a hole in the panel with a knockout. Just use a knockout tool to do that. And then you put this piece here through the hole, and this comes on the back of the panel. Then you simply twist it to the right, and it's locked in place now. I can't pull them apart. And then to tighten it up, that's where you use these screws here. And what happens is the panel itself sits right in here, and these screws, you just draw them up tight and they'll push against the inside of the panel, and they'll just put tension on it, as you can see, I think, to hold it in place. So it'll tighten things up that way. That's how you mount them on the panel. With these two screws here are the way to tighten it up on the panel itself. Once you have it mounted on the panel, of course, this is the front side, and this is the actuator itself. And you just press in on this. This is, it'll press in. Okay. And on the back side, you can see the plunger that is pressed in. So you get that kind of action. And then you have options on the back side. You could, for example, put a normally open contact, color-coded green, on the back. And what's going to happen is that plunging action here is what's going to push on the plunger of the actuator, of the contact itself. So that's going to push that in. I can show you that here. So, I mean, it's going to get pushed in. Yeah, this will get pushed in. Okay. Yep, like that. So that gets pushed in, and you can actually see. Let's put it all together here. You'll see it all together. To mount the normally open contacts on the back of the push button, you would do something like this. There's a screw here that mounts. So that's going to be what you would use to fasten it. Let me do that for you. We can use this one maybe. It's a little tricky to do all with just two hands. Okay, so that's going to screw on there. Let me do that for you. Okay, so now I have that in place, and I bolted it on. You can see with this bolt here, I bolted it onto the frame. Now when I press the actuator on the front side, right, I'm pressing it. If you can see me pushing that in. That's going to push the plunger in. That's going to push the switch contacts together. And you can see that happening on the back side. If you look right here, right here is a good indication. Watch. Do you see that movement? So that's telling you that the whole system's working. When you look on the back side, you can see the motion of this plunger coming out. Electrically, what's happening is you're just connecting these 2 points. So you do have 2 screw terminals on the normally open contacts here and here that get connected when you press whatever actuator you have this contact connected to. And those are just clamps. You know, so you would fasten your wires right in that clamp. That's one side of the contact. Here's the other side, of course. Yeah, so you just clamp the wires in place there. I could put a second set of contacts on. And in the case of this actuator, I mean, they're going to be actuated simultaneously. When I press the button, you can see. When you're trying, if you don't know, you can just look on the back and look for that. See how both plungers? So you can always check that. The contacts are stackable. I mean, I could just keep going however deep the box allows me to go, you know. So I could put 4 normally open contacts on if I want. Perhaps there's a use for a normally closed contact, and that would be color-coded red. I could put one of those on. Now I have one of each. So what I really have is a push button that will close the green contacts when I press it, but also it will open the red contacts. So these contacts from side to side, you know, here's the same wiring scheme, just 2 clamps to screw down. And there's going to be a normally closed situation. So this is closed, and when you press it, it opens. Okay. So, but it looks the same as far as the plunger. I mean, the plunger action doesn't stop, right? The plunger is still just coming through. If I can get the light on there, see how so it's coming through both. So it looks the same. The action looks the same, but these contacts are closing. But the red contacts will be ones that are opening because they're normally closed contacts to start with. Okay, so that's the push button. Now, of course, we have other types of actuators, and I can just I can switch out the I don't have to take the contacts off the back. I can just change the actuator itself. So I would just untwist this and pop it off. I can pop on another type of actuator. Maybe I'll just put this one on actually without contact blocks first. Let's just have a look at it. This is just a 2-position switch, okay? And what's going to happen on the back, you can kind of see the plastic positioning changes with that. So what does that do to contacts? Well, again, you can use a visual inspection. Of course, you could use your own meter too. But I just snapped it on here to where we had a normally open contact. And you can see, I think, where the position of the switch, what it does. Okay. So I can see here the actuator moving the plunger in and out. Get that on the light just right. Okay. There are many different configurations, and different actuators will behave differently. So it's important to get to know what one you have or what one you're looking at. For example, when we really get down to it and look at this, of course, it is a 2-position actuator, but the question is beyond that. It's what's happening with those plungers on the back. And I can see just from physical examination, when it's to the left, both of those are retracted, and when it's to the right, they both go forward. And when I say both, I mean both sides. I mean, some actuators, you might have it where they actuate to the left, they actuate the left one, to the right, they actuate the right one. But that's not the case here, so that's really important to know what you have. So we have one that actuates both sides to the right, and then nothing to the left. Yeah. Okay, so that's good to know. And again, we can put normally closed contacts on there too if we wanted to. So the configuration, whatever you need, you can do that. And I put one of each of the contact blocks on here, a normally open and a normally closed, just to show you a configuration that you might use if you wanted to mimic a single pole double throw type action. So when the actuators to the left, the plungers are in, which means for the normally closed contact, these contacts are closed and the green contacts are open. And then when I throw it to the right, the red contacts open and the green contacts close. So since we have the type of actuator that actuates both sides on the movement to the right, I would use a red and a green. I would use a normally closed and a normally open. And now I've got switching action where these are closed, in the red contacts are closed in that position, and the green contacts are open. Now the green contacts are closed and the red contacts are open. So you have to think it through sometimes, and a lot of it depends on what type of actuator or even what type of block you have here with, you know, with what your choices are, and just important to understand all that and keep it straight for whatever application you're trying to do. And finally, one last look at why that's happening. I mean, for this actuator where we just have a 2-position, this particular one, you can see, I think, in one position, both sides have that valley, right? So the valley is there for both plungers in that position. So both sides, there's no plunger pushed. And then when you turn it, both plungers get pushed. So again, valley on both sides. Now both sides are pushed in. See? Okay. Now here we have a 3-position switch. So it's got a left position, a center position, and a right position. And if you look at the actuator back here, again, it's twist locked. I mean, it's put in place into the same base. You just kind of put it in there and snap it in place. In the left position, I think you can see from that white plastic, the left contacts. That plunger would be pushed in. And then to the middle, I think you can see neither side, neither contact, you know, that stem or plunger, whatever you want to call it, would not be pushed in. And then on the right, when you turn it to the right position, I'm in the right position now. So in this position, the contact's on the right, speaking right along here. So that's a nice way to see it. Predict what's going to happen. It's this raised plastic that's going to push the plunger in on this side. In the middle position, neither side has any raised plastic to push the plunger, and then on the left side, only the left side is pushed. Okay, so that's one way to see it just from a visual inspection, and then let's put some contacts on there. We'll see it again. So here I have that same contact block, same actuator with contact blocks bolted on. And again, I just did that with this bolt here, and then I can bolt another contact block, sort of piggyback right onto it with its bolt. Okay, and we'll see that same action that we predicted come true. So in the center position, if we look on the back, we see that no contact blocks, you know, no plungers are pushed. So these are green, so they would be normally open, and all of the contacts, all 4 of them, are open from here to here, here to here, here, and here to here. Now I'm going to throw this actuator to the left, and as predicted, we should see the left side activated, and it is. Do you see that? There's center, there's left, there's center again, and I'll go to the right. There's the right. So this one's pretty intuitive, or at least easy to remember, I should say. When you go to the left, we basically connect these contact blocks become closed. And when I go to the center, no contact blocks are closed. When I go to the right, these 2 are closed. I mean, when I say these 2, I mean these blocks as a whole, but it's connected from here to here and here to here. So we have 4 normally open contacts. 2 of them closed there, none of them are closed, and other 2 closed there. Yeah. This is the switch that we'll use for the first exercise, where we mimic, you know, the H-bridge switching, but it's just a 3-position switch, and we can get a motor to be off. We can get it to go reverse, off, and forward. The 4 normally open contact blocks just have to be matched up to the switching that an H-bridge would do. Now you might get a funny look if you call this an H-bridge. I mean, it's a 3-position switch that's doing reverse, forward, and off for a motor. So I don't know that people would call it an H-bridge. I do, just as a quick reference. H-bridge, that term is usually reserved for if you're using transistors to do the switching. You would have 4 transistors in an H-bridge configuration, and that's typically what terminology is used for. I use it as a quick reference. So, but we will do the 3-position switch as our first exercise, and it's your job to match up these contacts to do the same switching that we showed in the theory session for the H-bridge. And I'll give you one helpful hint. Don't make the mistake of thinking that it's just that the physical orientation matches up. It does not. In other words, you know, the H-bridge where we had a contact, a contact, a contact, a contact, and you're loading the center, if you remember. And these two had to turn on, or these two. Don't make that association physically with these, okay? Because remember, from the actuation we just observed, these two don't turn on at the same time. These two turn on at the same time. And these two turn on at the same time. So enough said. I mean, just sometimes I see students just without thinking, they just try to physically put this thing right next to the drawing of an H-bridge and match things up just pictorially, which is a mistake. Okay, so to be totally clear, the hint that I'm trying to give you is that the H-bridge normally open contacts, there's 4 of them, and there's 4 of them here. Don't do this. Don't make that association. That would be incorrect, right? This contact is not necessary. These don't match up pictorially, okay? So that's the big hint for what not to do. And I think you know, I mean, these have to close at the same time, right? Not these. That's a dead short. So if you do that, you will cause a dead short. And hopefully the power supply survives. So these have to close for one direction of the motor, and these have to close at the same time. So there's your matchup. There's your association. These two contacts could be these two, and these two could be these two. Okay. And also remember that if it was this actuator, that would change the game, right? This is our 2-position one. So if you didn't want a center off position, if you just wanted to reverse polarity, just with a throw of a switch from one spot to the other, remember this actuator fundamentally works differently. So you would have to rethink all that, take all that into account, that you'd have to use maybe different contact blocks, and again, just make those associations correctly, not incorrectly. So, you know, it just takes a little bit of thought and examination. Probably for that example, you would put normally closed contacts on one side, and they would be a pair of contacts for you. But it would bring up other issues, such as the fact that I would want to be certain that the normally closed contacts broke open before the other one's closed. Otherwise I would get shoot through, I'd get that short. So you would need a little more confidence that your contacts are going to break before the other set makes. So I don't know that you would ever even use this kind of an actuator. You'd be relying on those plungers and those switch contacts opening before the other ones close, and I don't know that I could guarantee that. So yeah. Anyway, just some more food for thought. We have some other actuators. This is sort of a dual actuator. It's a sort of a classic, you know, you have the start and the stop buttons to press. Now this one has an actual indicator light in the middle. I've gotten away from using it because, strangely enough, the actuators themselves tend to want to move together, even though the plungers do not. So I thought that would be nice to have an indicator light, but I opted away from this because of that problem. But I don't have one of those other ones with me, so I'll just show you this one. It again, you know, it just twists on. Now you won't have that indicator light sitting in there for the middle because of what I just said. But with this, it's pretty typical that you would have the green actuator activate a normally open contact block. So whichever plunger that one is, that's the one that you would attach the green to. So let me go ahead and do that, and we'll have a look at it. And here I have the contact blocks attached where I want them. So if I press the red actuator, you can see the red contact block is the one that's being activated, and it's a normally closed. So what's happening is I'm breaking the circuit open here. Okay. And here, the green, when I press the green contact block is actually activated. So I'm closing those contacts. So this will break open the red block contacts, and this will close the green block contacts. That's typically how we'd use that. Here we have an e-stop, an emergency stop, e-stop for short, also known as maybe a panic button. It is usually just like some kind of mushroom shape. And the intent is, I mean, it does the same attachment, you know, twist it on and then tighten up the bolts to the cabinet. But here you can just hit that button. It'll just press in and it'll stay in. Now, you can get ones that don't, but most often they do. And you see this arrow tells you the direction that you twist it to unlock it, and it'll pop out. So it snaps in and stays in, but then you twist it to release it. Okay, just like that. And the contacts that you'd put on the back, well, let's get into that a little bit. We'll put some on there. So here I put a pair of normally closed contacts on, which is what you would use for a safety circuit. And what happens is when you press that, it breaks open the circuit, and when you release it, the circuit's restored. And it's not uncommon to have maybe redundancy, so you could even have two contact blocks, and that way when you press it, if for some reason this one wouldn't open, if they're wired in series, which they would be, then this one will still get the job done as far as breaking the circuit. So redundancy is something that you'd possibly see. If you want to monitor that redundancy, because you wouldn't really know if one of these contacts did get stuck, it would still work, but so you wouldn't know that you lost your redundancy. That's the job of a safety relay, and we'll get into those maybe in the spring. We'll talk more about some of the more complex circuits around that. But you might have some redundancy there, whether it's monitored or not. What we'll do for our little exercises, though, I mean, one will be sufficient to make the case for the safety circuit. You know, stopping things. We'll do that with a single contact. We can also use a normally open contact on there, and so that means when you press it, this one will close. And we'll just do it as a matter of convenience to illuminate a red light. For some of the trainers we have, this is actually a clear plastic, and you can illuminate the red light itself with these green contact blocks connecting and turning on the red light. All I'm using that for is to make it easy to see when this is pressed. You don't have to try to guess. You can see a red light that shows that e-stop needs to be reset. It needs to be twisted to be reset. You know, and for some of the trainers, you know, we'll have our own little red indicator LED, and the terminals are right here. There's no polarity. It's okay either way. And it's going to just sit there, and when you press this, the e-stop will use just a green terminal block to turn on a red light that lets you know that the e-stop is pressed in, just as a convenient way for the operator to see that. Then we also have an illuminated push button, which means it's a push button like we saw before, but it has a light in it too. And so we have this light, and the terminals for the light are right here and here on the back. And that'll light up the push button itself. We'll also attach contacts to it. And for this one, probably we'll be using normally open contacts. And it's convenient if you can put the contacts on the side that allows you still to have access to the lamp. You can stack contacts on either side, you know, but of course it makes sense if you do it this side, if you don't need too many contacts. And I think one is all we'll need for most of the exercises, or all the exercises. And the idea here is this control will be a reset for the safety circuit. When we get to it, you don't have to understand the safety circuit yet, but just giving you a heads up. That's what it would be used for, and you would have this yellow light lit to tell the operator, hey, you have to push this to reset the safety circuits. So if you hit the e-stop, The red light comes on telling you that the e-stop is pressed, and the yellow light comes on to tell you that the safety circuit has in fact been activated and will need to be reset. Okay. And then finally, some of the other industrial controls that we'll use in the early activities. There'll be some more illuminated push buttons. These are all illuminated push buttons. There's a green, red, and yellow, green, red, and green push button that are all have lamps in them. For the very first exercise, where you're just using the 3-position switch to control a simple motor that, forward, reverse, and off, you can use these lamps. You don't need to use the push buttons themselves, but you can use the lamps to show maybe forward, off, and reverse. So there'll be a nice indication of what the motor's doing. So you can use that for that. Towards the very end of the 1 packet, we get away from, the fixed position type of control, which is what we have with a 3-position switch. So we do away with this, and we show you how to use seal-in circuits to actually press that button and it's going forward. Press this button, it stops. Press this button, it goes in reverse. And we also interlock the seal-in circuits so that you can't reverse it if it's going forward. Now those terms, seal-in, interlock, they'll all become clear down the road. We'll show you what that's all about. But just to give you an idea of the functionality here that we have built in. So for these, I would say, typically we're going to have a normally open contact on the back of that push button bolted on. And when you press it, that's what'll latch a relay to go forward. And if you press, or when you press the red to stop, you'll need a normally closed. So that means you press the red button and those contacts open, and that will stop or unlatch some relays. And then to get going the other direction, we'll have a normally open contact here, and you'll press that to start in the other direction to reverse the motor, and that would latch a different relay. So just to give you some idea of what we have as far as what all the panel controls will be. So altogether, these are the push buttons, switches, indicator lamps, e-stops that we'll be using in the beginning exercises. You'll have something maybe close to this arrangement if you have a portable trainer. The ones that are fixed to the benches will have a different layout than this, but you'll be able to sort of still figure out, I think, where the things are at that you need. And like I said, the early on, to just get you started, the very first exercise, we'll use this this 3-position switch to go forward, off, and reverse for a motor. And the indicator lamps here would be a logical choice. You can use those 3. You don't need the push buttons to start. You just need the indicator lamps themselves. And I think the second exercise then, you'll be using something like, you'll be adding a safety circuit, and we'll actually, for the motor, we'll just use an on-off. So we'll just use this 2-position switch and the safety circuit. So just to give you some idea of where to go for what you'll need to do the exercises. The second exercise, I believe we just turn the motor on and off. We don't worry about forward, reverse, and all that, because we'll come back around to that. But gives you some idea. So this would be exercise 2. Exercise 1 will use this and the indicator lights. Exercise 2 will use sort of this stuff. Exercise 3 will start incorporating this, and so on. So I can probably put a little map together for you. Okay.